Hey there, this is Dr. Rishi from the Learners Academy, and today we are going to talk about a very interesting topic in physics. It is light. Light is one of the most important topics that we talk, because if we don't have light, we can't see. When I say light, we are talking about the visible spectra, that is the visible light. Light is a part of a spectra called as the electromagnetic spectra. Light itself is a very complex thing to understand, because light depends on the person who's observing it. So light basically can be categorized into three parts, or depending on the observer, the light can be of three different types, or depending on the observer, the light can take three different forms. For a stationary observer who is looking at light in a macroscopic manner, light is considered as a ray. So when we teach light at younger classes, standard 4th, 5th and 6th, we generally call light to be a ray, or it is always considered as a ray of light, where the ray passes so there are certain characteristics that the ray takes, that the ray follows. One of them is light light follows a rectilinear motion. Rectilinear motion meaning light goes in a straight line. Now, if we as we go deeper in studying light first is considered as an electromagnetic wave, and then it is considered as particle. So if we are going to consider light waves coming together and mixing with each other, then we consider light as a wave, light as an electromagnetic wave. So it is a combination of electromagnetic wave. It has an electrical part and a magnetic part, and it behaves in a pretty complex manner. Then we have the last form that light can take, and that is if you look at light in microscopic manner, then light is considered as a particle of photon. Photon is a massless particle. It is particle of light, and it is characterized by its speed. So it is massless, meaning its mass is 0 at rest. So if it would exist only if it is moving. So it would be energy which would be considered as a mass. Now this is slightly complicated to understand, because we are having a relativistic approach. When I say relativistic approach, I mean we are considering the theory of relativity given by Albert Einstein. In this video, we are just introducing what light is and how light would be behaving as a ray. In this video, we are going to consider light to be behaving as a ray. This topic in physics is categorized as ray optics. Okay, so we need to have our ground rules set here. We are going to talk about visible light, and we are going to consider it as a ray. Light has been considered as a ray for almost 2000 years now, since we've been discussing light since very early ages. The philosophers then and later the scientists have considered light as a ray. So when light behaves like a ray, two major phenomena that we discuss are reflection of light and refraction of light. Reflection of light basically means bouncing back of the light from a specific surface. The most common surface that is used for reflection of light is a plane mirror, which we use in our everyday life. It is daily used. So for instance, if we are combing, we would use a flat mirror or a plane mirror to see our image, and then we can comb our hair, or for that matter for shaving, or for that matter for applying makeup. Now these are the the basic uses that we have in our daily life. This same mirror, if it is slightly curved, it can be used in optical instruments like telescopes and microscopes, or maybe dentists use it, or we can also have them as corner mirrors in malls and parking lots. So the phenomenon that governs all these is reflection. First, we are going to discuss reflection on a plane mirror, because this is the easiest topic to understand. So let us go ahead and see how plane mirrors would be behaving, or how they would reflect the light. Now here I have a plane mirror in front of me. So we are going to use this plane mirror to study reflection of light. So let us go ahead to our experimental setup and see what happens. So here we have an arrangement where we have a foam sheet which is holding the mirror, and then there are different angles drawn on it. So if you can see, this is 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees, and same way 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees on the other side. Okay, so this is going to give us, so we can use this particular setup to see the law of reflection that is there. The law of reflection states that angle of incidence is equal to angle of reflection. So let us first understand what is angle of incidence. Angle of incidence is the angle at which the incident ray is the ray that is coming in, is making with the normal. So what is the normal? The normal is the perpendicular to the surface. So in this case, if this 30 degrees is considered as my incoming ray, then so I'll call it as the incident ray. And if the 0 degrees is, if you see, it is perpendicular to the surface which is reflecting, so it would be called as the normal for the surface. So the ray the law basically tells us that the angle of incidence would be equal to the angle of reflection. So now let us see how it works. So I have kept my setup in here, and what I do is I would take a pin and I would put it on, say, 30 degrees. So I will take a pin. So here I have a pin in front of us, and what I'm going to do is let us put it on, say, this 30 degrees mark. Now I've put one pin here. I will put one more pin in on the same line. So if I put one more pin here, then they should be in the same line. So let us see where the reflected ray is formed. As you can see that at this particular point, both these pins are in the straight line. So if I move it, you can see that there are two pins, but if I bring them together at this particular point, then both of them would align themselves in a straight line. Now here we can see 4 pins, 2 original pins and the remaining 2 are the images. So these are the pins, these are the real pins, and these are the images. Now let us move the camera a bit and we would see when these pins would align themselves. Now you can see that you can see only 3 pins, the first one, the second one, and then we have 2 coinciding each other. So this is the reflection of the first two pins. So to understand what is happening here, we are going to put two more pins in such a way that all these four pins are there in same line. So let us go ahead and put these two pins. So this is my first pin, and then this is my second pin. So now if you'll see, all the four pins are exactly in the same line. If seen from the top view, these are our first two pins, pin number 1 and pin number 2, and then these are the next two pins that I have put in after I saw the reflection of the first two pins. If you see, my first two pins are on the 30-degree line and my next two pins are also on the 30-degree line, proving that the angle of incidence, so this, in this case, it is going to be the angle of incidence. I'd like to repeat it one more time. The angle of incidence is the angle between the incident ray. So in this case, this is the incident ray and this is the reflected ray, and this is where I am going to measure the angle from. So this I can call it as my normal, which is considered as the 0-degree line, and it needs to be perpendicular to the surface of the mirror which is reflecting the light. So this is the incident ray and this is the reflected ray. So if we measure the angle between the normal, that is this 0-degree line, and this 0-degree line, then both these angles need to be equal. Hence we have proved the law of reflection, which says that the angle of incidence is equal to the angle of reflection. Now this was about a reflection of light by a mirror, by a plane mirror. Now let's go ahead and see what happens if we have more than one mirrors and how they would be, what they would be doing. So now this is also a very interesting topic. So if we have multiple mirrors, they would be producing multiple images in a very specific manner. So let us go ahead and discuss how, if we have two mirrors and we are putting them at an angle with each other, how many images they would be producing. So if the angle between two mirrors is 30 degrees, then this is what we are going to see. If I increase the angle to 45 degrees, this is what we would see, and these are the number of images that we will be seeing. If the angle is further increased to 60 degrees, this is what we would be able to see. At 90 degrees, this is what we will see, and at 120 degrees, this is what we are going to see. So this was about getting multiple images using two mirrors at an angle with each other. So let us talk about two types of reflection that we generally get. One is a smooth reflection and one is a rough reflection. If the surface of the mirror is like this, which is nice and shiny, we will be getting a really clear and crisp images in it. So this kind of reflection is called as smooth reflection. On the contrary, if this mirror gets scratched by some means or the others, like I have done here, then I would be getting a rough reflection, where the rays, if you see, the surface is not polished nicely, or there are scratches on the surface. So we see the reflection partially, however, the reflection is not clear and crisp. So it would reflect light, However, it would not reflect light like a plane mirror. So the reflected rays would pretty much mix up with each other, giving us a rough image or a very crude image for that matter. Yeah. So this was about a reflection of light from a plane mirror. I wanted to do reflection and refraction of light together. However, it would become a really extended video, so we are going to break it into two parts. This video we are going to talk about reflection. In the next video we are going to talk about refraction of light and Snell's laws. So that was it from my side today. If you have found this video helpful, please like it and share it with your friends, and don't forget to subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.